Good day to all of you. Today we shall have introduction to databases. Our sincere acknowledgement to authors Ramesh Elmsari and Shamkant P. Nawate, authors of the textbook being Fundamentals of Database Systems. In that first chapter, databases and database users. First, let us know what is database management system, that is DBMS. A database management system is a system software. It serves as an interface between database and end users or application programs. If you see to the figure here, this is computer storage medium, say hard disk. In this related data, which is called as database, that is stored. Users are here, they will be writing commands or application programs. This DBMS software, which is acting as interface between users and database, it is a set of programs. It allows user to store the data, and whenever they require, they can retrieve and update the data. So DBMS software not only manages the data, it also stores the database structure onto the storage medium. It allows users to give commands for data storing, accessing and modifying. It may lock the data also. It may not allow unauthorized users to access the data. So DBMS software not only stores the data, manages the data and database structure, but it also provides protection to the database. And that is what is database management system or DBMS software. Okay. Next, let us see to some basic definitions. Database. It is defined as collection of related data. Then what is data? Known facts. Facts means truth from real life which can be recorded and which have implicit meaning. Then what is mini world? This is part of the world about which we store the data in the database. So some part of real world about which data is stored in the database is called as mini world. For example, student grades and their performance details at a university. So that is an example for mini world. Database management system, as already discussed, it is a software so that facilitates user creation and maintenance of computerized database. Database system, the DBMS software together with data and sometimes with the application programs or users command, all the three together it is called as database system. These are the some of the basic definitions. What is simplified database system environment? Database system environment has database, DBMS software and users application programs. All the three together it is called as database system. So the figure shows simplified database system environment. Here we have users and here we have computer storage medium where data and data about data, that is complete description of database which is called as metadata, that also is stored. And this who is the intermediate here, DBMS software, which acts as interface between users or application programs and database here. So users will give the commands or application programs in which they will be writing the instructions to store or retrieve or manipulate the data here, and those will be sent to DBMS software. It has set of programs to process users queries. So what commands users write to access this database, they are called as queries, or set of queries is also called as programs. So DBMS software has set of programs, that is software to process users queries and programs. And also it has another set of programs, say software to access stored data. So it is a general purpose software. It facilitates the user to define, construct, manipulate and share the databases among many users and applications. First, the users have to define the database, which involves specifying the data types, structures, and constraints of the data to be stored in the database. Complete description or details of the database is called as metadata, and it is stored in a file called database catalog. After defining, the users can construct the database. It is the actual storage of data. It is the process of storing the data on some storage medium that is controlled by DBMS. Manipulating involves writing commands, that is querying the database to retrieve specific data, update the data to reflect the changes that do take place in the real world or mini world. So user may generate reports from the data, or he may share the database among multiple users. So user will be sending queries or set of queries which are called as application programs. So these queries are sent to DBMS software. So a query typically causes some data to be retrieved. User may perform transaction also, in which some data is read and some data is written onto the database. So whatever user sends queries, DBMS software executes them so that from memory the data is accessed by users and they can manipulate, they can share among multiple users or application programs. The other important functions of DBMS software are protecting the database and maintaining it over a long period of time. Here protection means system protection against hardware or software malfunction, security protection against unauthorized or malicious access. The DBMS must be able to maintain the database system by allowing the system to evolve, means to make the changes as the requirements change over the time. So as a summary, what are the different functionality that the DBMS software can provide? So DBMS software allows the users to define a particular database in terms of its data types, structures and constraints. It allows users to actually store the data in the storage medium, that is construct database in the computer memory. Then through queries manipulate the data, means they can access the data, modify and do updates, and they can access the database through web applications. So processing and sharing by a set of concurrent users and application programs, keeping all the data valid and consistent, is provided by DBMS software. Another functionality is it can provide protection or security to the data, and it can protect the data from unauthorized users access and protect the data from system malfunctions. It can allow the users to do active processing on the data. Then it provides presentation and visualization of the data in terms of graphs, tables and descriptions. So it maintains the database over a long time. It is called as database software and system maintenance. So these are the functionality that is provided by DBMS software. Okay. We shall discuss example of a simple database, that is university database. Database means collection of related data. So here university database means the related data in an university, that is data regarding student, course, section, grade report and prerequisite are stored. University database is used for maintaining information concerning students, course, grades in a university environment. This figure 1.2 shows the database structure and few sample data records. To construct university database, we store data to represent each student, course, section, grade report and prerequisite as a record in appropriate file. The database is organized as 5 files. The student file stores data on each student. Course file stores data on each course. Section file stores data on each section of a course. The grade report file stores the grades of students that they receive in various sections they have completed. The prerequisite file stores the prerequisite of each course. With that, department and instructor details are also stored. First, to define this database, we must specify the structure of records to be stored in each file. Each student record includes data to represent student name, student number, class, major, which is shown in student table here. Each course record has course name, course number, credit hours and department, which are shown in course table here. We must also specify a data type for each data element within a record. For example, name of student is a string of alphabetic characters. Student number of a student is an integer. Grade of grade report is a single character from the set A, B, C, D, F, I. We may also use coding scheme. Instead of storing freshman, 1 can be stored to represent freshman, 2 means that student is regarded as sophomore, 3 means junior, 4 means senior, 5 means graduate student. So instead of storing string data, the data can be stored in the form of numbers. So this is called as coding scheme. The database manipulation involves querying and updating. So example queries are as follows. Retrieve the transcript. That is a list of all courses and grades of Smith that is to be retrieved. For that a command is to be written and that is called as a query. Similarly, another command or query is to be written to list the names of students who took the section of database course offered in 2008 and their grades in that section. Third one, list the prerequisite of database course. So for all these three purposes, the commands what users give to DBMS software, they are called as example updates are change the class of Smith to sophomore, create a new section for the database course for this semester, enter a grade A for Smith in the database section of last semester. Using querying language of DBMS, queries and updates must be specified precisely before they can be processed. Means user, whenever they store the data onto the storage medium, retrieve the data or do manipulation, they'll have to give commands or set of commands to the DBMS software. These commands are called as queries. Okay, that is all about an example database, that is university database. What are the main characteristics of database approach? There are four main characteristics of database approach. That is, first one, self-describing nature of database system. Second one, insulation between programs and data abstraction. Third one, support of multiple views of data. Fourth one, sharing of data and multi-user transaction processing. Next, we shall see what are these. The first one, self-describing nature of a database system. DBMS software not only stores data, it also stores data about data or complete details of the database, which is called as metadata, and it stores metadata in DBMS catalog file. So whenever it requires, it will access this. Since DBMS software is a general purpose software, it can work with any kind of database applications, because whenever it requires details of database, its structure, it will access from the memory, that is from database catalog file. So that is what is self-describing nature of database system. For example, if you see into the figure here, the relation name, that is student, that is table name. How many columns it is having? 4. So one more table, course, that is having 4 columns. Likewise, details of all tables, like how many columns it is having. Then column name, if it is name, what kind of data it is. So name is a string of 30 characters. Then student number is string of 4 characters. Class is an integer of 1 digit type. Major is major type. Course name is another string of 10 characters. Likewise, here what tables and how many columns it is having, and each column data type is what. So that is what is complete details of database is stored in the memory by DBMS software, and that is called as self-describing nature of a database system, because of which DBMS software is able to handle any different database applications. That is all about first characteristic of database approach. The second characteristic is insulation between programs and data abstraction. So DBMS stores data and data structures separately. Means data and data about data, that is metadata, it stores separately. So with this the user can change the data structure without changing the programs. So there is program data independence. Data and description data load separately is called as insulation here, because of which user can change the data structure without having to change the programs. Data abstraction in DBMS means hiding unnecessary background details of the data from end user to make accessing of data very easy and secure. The insulation between programs and data abstraction, they are the very important concepts in DBMS. They allow the user to change the data without changing the programs that use it. The third characteristic is support of multiple views of the data. The database will be used by multiple users. So different users have different requirements. So depending on their purposes or requirements, they will be seeing the part of database. For that they will be querying. Then only part of database will be displayed on the screen. So in university portal there can be many users such as students, teachers, head of the departments, deans, etc. Instead of having separate database for everybody, which will be wastage of resources, but single database is maintained, but as per user's query depending on the requirement, part of the database is displayed, that is called as view. For example, this is transcript view where only transcript table is displayed. Here this is course prerequisite view. A view may be subset of database that is derived from the database files but not explicitly stored. Okay, so from whole of the big database, only part of the database being displayed as per the user requirement, that is called as supporting multiple views of the data. The last characteristic is sharing of data and multi-user transaction processing. So DBMS allows multiple users to retrieve from and to update the database at the same time. So that is concurrent users. Many users using the same database at the same time. For example, airline seat reservation. So DBMS has concurrency control also. It guarantees that each transaction is corrected or aborted. That is banking application. So transaction means it involves read operation, write operation, or deleting the data records. So banking transaction, if you take, whenever anybody tries to withdraw the money, first his balance is read, then amount how much he wants to be retrieved, that is deducted. After deducting, it is returned back to the account, then it is committed. After that, money is issued. So a series of actions which involves reading, writing, or deleting, that is called as transaction. So in movie ticket booking scenario, where DBMS should ensure only one user can book a seat at any given instant. So recovery system ensures each completed transaction has its effect permanently recorded in the database. OLTP means online transaction processing. It is major part of database application. This allows hundreds of concurrent transactions to be executed per second. So these are the four major characteristics of database approach. Next we shall discuss on the topic database users. There are many different kinds of users that use database. They can be broadly classified into two groups. The first one, actors on the scene. Second one, workers behind the scene. Actors on the scene means the people or users who use database. Workers behind the scene means the people or users who design DBMS software, its tools, and the operating and maintenance people. Okay. Under actors on the scene, there are three categories: database administrators, database designers, and end users. In end users, we have four different kinds of end users: casual end users, naive or parametric end users, sophisticated end users, and standalone end users. Under workers behind the scene, we have three types of users: DBMS system designers and implementers, tool developers, operators and maintenance personnel who are system administration personnel. This figure shows the hierarchy of database users. Next we shall see these one by one. Okay. Firstly, let us consider actors on the scene. In that first one, database administrators. These people are responsible for managing and maintaining the database. So, including they do the work of schema definition, security, and performance optimization. They are responsible for authorizing access to the database, for coordinating and monitoring its use, acquiring software and hardware resources, controlling its use and monitoring efficiency of operations. So the second one is database designers. They are responsible to define the content, the structure, the constraints, and the functions or transactions against database. They will communicate with end users and understand their needs. As per their needs, they design the databases. The third kind of users in the section actors on the scene, they are end users. So they are individuals who access the database for their daily tasks, such as querying the data, updating records, and generating reports. These operations they do. End users can be categorized into four, as already discussed in that first one: casual end users. They occasionally access and interact with database, not frequently. Each time they will have the need of different information from the database. They often need flexible query systems that can allow them to specify their information needs. Casual end users do not have deep technical knowledge of the DBMS. They are provided with sophisticated graphical user interfaces, and with that they can interact with the database system. The examples for casual end users are middle or high level managers and other occasional browsers. The second type of end users is naive or parametric end users. So they frequently access the database. They will not be familiar with the database structure and complex SQL queries, but they will be knowing how to use the database through interfaces. So large section of end user population belongs to naive or parametric users. So they use some previously well defined functions. For that they will be providing input parameters and they get transactions or DBMS operations done. For example, bank tellers. So they provide to some well-defined functions the parameters needed and they get the processes related to deposit done. Similarly, reservation clerks, they will be providing input parameters to their well-defined functions or transactions and get booking of the corresponding flight done. Okay. So that is all about naive or parametric end users. Next, third kind of end users is sophisticated end users. So they frequently access the database. They will be having good understanding of the database structure and They have specialized knowledge and skills related to database and its system. They can write advanced queries using tools and software packages which closely work with the stored database. The examples of users who belong to this are database administrators, database analysts, and software developers who can design, implement, and maintain complex databases and applications. Database administrators are the people who are responsible for managing and maintaining the database. Data analysts who use database to analyze and interpret data. So they will be using required advanced querying and data manipulation skills. Software developers develop applications or programs that interact with databases, needing a strong understanding of database concepts. Application programmers implement specific application programs to access and manipulate data stored in the database. The fourth and the last one under end users is standalone end users. Standalone end users, they manage databases for personal use or small business purposes. For example, tracking personal finances, managing a small collection of data. For this, they'll be making use of pre-built data applications with easy to use interfaces like menu based interfaces or graphical interfaces to interact with their databases. Okay, so with this, four different kinds of end users is completed. So far we discussed actors on the scene, in that database administrators, database designers, and then we completed four different kinds of end users. Next we shall move on to discuss in detail about workers behind the scene. The second broad category of database users is workers behind the scene. So the people who design and develop DBMS software, related tools, and the computer system operators do fall under this category. So DBMS system designers and implementers design and implement DBMS modules. So DBMS software is a set of programs. So these set of programs, they are called as modules. So they also design interfaces as a software package. So these modules include modules for implementing the catalog, query language processing, interface processing, accessing and buffering the data, controlling concurrency, handling data recovery and security. So DBMS must interface with other system software such as operating system and compilers for various programming languages. So all the different programs which are there in the DBMS software, they are designed by DBMS system designers and implementers. Next, the tool developers. They design and implement tools. Tools means optional software packages. They are often purchased separately. They include packages for database modeling and design, database system design, for improving the performance monitoring, natural language and graphical interfaces, prototyping, simulation, and test data generation. In many cases, independent software vendors develop and market these tools. The third one is operators and maintenance personnel or system administration personnel. So they actually run and do the maintenance of hardware and software environment for the database system. So that is all about database users. Next, what are the different types of databases and database applications? So for traditional applications, we have numeric and textual databases. More recent applications do have multimedia databases, geographic information systems, that is GIS databases, data warehouses, real-time databases, and many more. Some popular DBMS include MySQL, Microsoft SQL Server, Oracle, and MongoDB. So for traditional applications, we have numeric and textual databases. These kind of databases are used to store and manage data like numbers and text. Modern applications. For that, we have multimedia databases which are used to store and manage media like not only text and numbers, images, audio, video, and along with that text may be stored. So third one, geographic information systems, that is GIS databases, used to create maps, manage infrastructure, and analyze data for crime prevention. Data warehouses, these are used to store and analyze data for business intelligence, reporting, and more. NoSQL databases, a collection of modern database types that differ from relational databases. They offer more flexibility and scalability. Data can be stored quickly and easily in NoSQL databases. Real-time and active databases. In simple terms, data keeps changing frequently and gets updated regularly in such kind of databases. Traditional database requires clients to actively query for update the data, whereas real-time database automatically provides changes in data to the connected client. Example, MongoDB. This modern database type differs from relational databases. In MongoDB, data is stored in the form of collections, not in the form of tables, as it is stored in relational databases. It can handle large volumes of data and has flexible data storage. The data can naturally be stored in the form of JSON format. These are used in video conferencing, gaming, and geolocation services. Many other applications used in industries include healthcare, finance, education, retail, and manufacturing. DBMS systems, which are used in such sectors, help to make informed decisions and provide better customer service. These are some of the database types and their applications. So next we shall discuss what are the advantages of database management system over traditional file system. File system is a way of organizing data onto hard disk in the form of files. So this started when hard disk came into existence. DBMS is another kind of managing the data. So it is a software which is used to store and manage the data onto hard disk. Both are different. So DBMS has several advantages over traditional file system. The first one is better data security. DBMS provides centralized approach, means only one database will be maintained. It provides security features including encryption, authentication, and authorization to that database, and hence it can prevent illegal access, alteration, or theft. It safeguards sensitive data against both internal and external attacks. Second one is reduce data redundancy. Redundancy means having multiple copies. DBMS keeps a single centralized database where file system has multiple copies. Here in database management system we don't have multiple copies. It keeps single central database and offers method for sharing and reusing it. This removes data redundancy, which reduces data storage space and increases data consistency. Consistency means correctness of data. Improve data consistency. Because of DBMS, which enforces constraints and data validation rules, it ensures that data is accurate and consistent, means the data has same value across different application and users. Okay, the fourth advantage is improved data access and availability. DBMS has efficient data access and retrieval mechanisms which enable quick and easy data access for multiple users. So for multiple users, because data is always available, that is called as high availability. This is provided by DBMS systems. So the next advantage is improved data sharing. DBMS provides sharing of database. It promotes teamwork in the company. It enhances data uniformity, means the data having same value throughout the company. So next advantage is improved data integration. So DBMS integrates data from different sources. Then it enforces referential integrity, entity integrity, and domain integrity constraints or rules. This guarantees consistency, that correctness, accuracy, and completeness of the data. So next advantage is improved data backup and recovery. DBMS provides backup and recovery mechanisms that ensure data is not lost even in case of system failure. This guarantees business continuity and lowers the chances of data loss. The last one is data independence. The data independence means the ability of data to change the schema at one level of the database without having to change the schema at next higher level. Users can work with data without being aware of its exact location or structure. Means where the data is stored and what structure it has got, it is immaterial. Whenever underlying hardware or software are modified, data damage possibility is reduced. It makes the system adaptable. These are some of the advantages of DBMS system over traditional file system. Okay. DBMS disadvantages. The first one is cost. DBMS software and hardware can be very expensive to purchase and maintain. Complexity. DBMS can be very complex to use and require specialized training. Next, scalability. As the database grows, the DBMS may need additional resources to handle the increased load. Performance issues. As databases grow, queries can become very slow. These are some of the disadvantages of database management system. Next we shall see to historical development of database technology or history of database technology. During 1950s, data was stored on paper in the form of ledgers, files and books. It required huge manpower, time to store and search, and the procedure was very tedious. During 1950s and early 1960s, magnetic tapes were developed for data storage. For inputting data, punch cards were used. In magnetic tapes also accessing data was sequential, hence it was very slow, and due to this technology was found inefficient. During 1960s and early 1970s, data was stored on hard disk. With this, direct access and fast access of data was possible. Data was stored on hard disk in the form of files. 1968s and early 1980s. This is era of non-relational database. IBM created hierarchical DBMS called IMS, which was very complex. Then Charles Buchman developed first DBMS with network model, which became popular. In 1970s, E.F. Codd, that is Edgar Frank Ted Codd, a British computer scientist who while working for IBM proposed a paper on relational database management, that is RDBMS. He is the first to introduce RDBMS, for which he got the highest award, that is Turing Award from ACM, Association of Computing Machinery. This prize is the highest award given for the achievement in the field of computer science and engineering. He proposed 12 rules for RDBMS, which today are known as Codd rules. 1970 to 1980s. Two prototypes belonging to RDBMS came into existence. System R from IBM, which later became IBM DB2. UC, University of California, Berkeley began prototype Ingress, which later became PostgreSQL. 1980 till present, SQL, structured query language, became industry standard for DBMS accessing and other related work. Parallel and distributed computing got developed. Object-oriented database systems evolved and found to be most suitable for most complex object-related real-world problems. During 1990s, large decision support and data mining applications were developed. Large multi-terabyte data warehouses were developed. Web commerce came into existence. Early year 2000, XML extended markup language and XQuery standards came into existence. Automated data administration started. Later year 2000, cloud database administration started. Example Google Big Table, Yahoo Peanuts, Amazon Dynamo. These are the examples for cloud database systems. These are very big data storage and management based cloud database systems. And that is all about the history of database technology, which started from the year during 1950s till today. Okay. The last topic is when not to use a DBMS. The main reason for not using the DBMS is its high cost. High initial investment and possible need of additional hardware is there, then DBMS may not be used because it has overhead also for providing generality, security, concurrency control, recovery and integrity functions. When a DBMS may be unnecessary. DBMS may be unnecessary if database and applications are very simple, well defined and not expected to change. The first one. In second case, if there are stringent real-time requirements that may not be met because of DBMS overhead, and thirdly, if access to data by multiple users is not required. In these three cases, DBMS may be unnecessary. When no DBMS may suffice. If database system is not able to handle complexity of data because of modeling limitations, if database users need special operations not supported by DBMS, in these situations no DBMS may be satisfactory or no DBMS may suffice. So these are some of the reasons and situations when not to use a DBMS. These are some of the topics in chapter 1. This is my first video on DBMS. In my next video, I will be covering chapter 2. I hope you understood. Thank you.